Hello students, Digital Image Processing. Songita Roy, Assistant Professor, Electronics and Communication Engineering Department, Narula Institute of Technology. Today's topic is Digital Image Enhancement, Frequency Domain Filtering in Digital Images, Low Pass Filter, High Pass Filter and Bandpass Filter. Image filtering, remove noises, sharpen contrast, highlights contours, detect edge and others. Image filter can be classified as linear, nonlinear. Frequency domain filtering in digital images. Frequency domain filters are used for smoothing and sharpening of image by removal of high or low frequency components. Sometimes it is possible of removal of very high and very low frequency. Frequency domain filters are different for spatial domain filters as it is basically focused on the frequency of the image. It is basically done for two basic operations, that is to smoothing and sharpening. So, frequency domain filters are low pass filters, high pass filter, band pass filters. Now, this below picture is showing how this frequency domain filtering is achieved. Input image in spatial domain, converted to frequency domain, then it is processed, then inverse transformation, and then output image in the again spatial domain is returned back. Ideal filters. Ideal filters are quick and easy to implement and gives an easy to understand appreciation of the filter. Unfortunately, ideal filters typically yield undesired results. Specifically, ideal filters suffer from a problem known as ringing artifacts, where extra lines appear around the edges of the objects in an image. Gaussian filter. The shape of the Gaussian filter transfer function is that of the bell-shaped curve that models the probability distribution function of a normal or Gaussian stochastic process. The smooth transition between the passband and stopband produce good results with no noticeable ringing artifacts. The cutoff frequency of Gaussian filters is determined by a variable omega. Butterworth filters. The shape of the Butterworth transfer function is tunable. The order of the filter determines the stiffness of the transition between the passband and stopband. It can assume a gentle transition like that seen in the Gaussian filters, or it can assume an abrupt transition like ideal filters. A nice aspect of Butterworth filter is that the cutoff frequency is a parameter of transfer function equation. Thus, it is simple to determine the parameters from examining the image in the frequency domain. And below pictures are showing the left one is the ideal filters, middle one in the Gaussian filter, and the last one is Butterworth filter. Basically, it is low pass filter showing filter parameters, distance function, cutoff frequency, bandwidth. These are the parameters which governs the shape of the or the characteristics of the filters. Distance function. To generate filter transfer function, it is necessary to know the distance of each element of the transfer function to the origin 0, 0. In filter transfer function equation, this distance to the origin is denoted as or simply as. Since the frequency domain data ranges from -infinity to +infinity both in horizontal and vertical direction rather than between the two specific distance, it is convenient to use a special function to calculate the distance. A function to build a matrix of these distances is included within the MATLAB code, and we will show you later. Cutoff frequency. The transition point between the pass and stop band of the filter is denoted as D0. Bandwidth. For band reject and band pass filter, where the data between lower and upper cutoff frequency is either rejected or passed, the width is denoted by W or omega. Now the low pass filter characteristics is shown below. Ideal low pass is shown by the first equation, and Gaussian low pass characteristics is shown by the second one, and Butterworth is the last one. Now high pass filter characteristics. For the high pass characteristics, the value of 1 for both A and B is common. So high pass characteristics is equal to A plus B of the characteristics of low pass. Similarly, for ideal, this one, and for Gaussian, H is equal to 0 for less than a particular frequency D0 and 1 for the rest. The second one is for Gaussian and the last one is for Butterworth high pass filter. Band reject filter is shown. The first one, the characteristics is shown for ideal band reject filter, Gaussian in the next one, and the Butterworth is the last one. Now band pass. Band pass filter characteristics is equal to 1 minus band reject filter, and it is shown by this equation. Now low pass filter characteristics is shown by if the input filter characteristics is HUV and AP is the input pixel frequency domain pixel information, then the after operation it will be GUV in the frequency domain, and corresponding inverse transform it will get back in the original spatial domain. This is the high pass characteristics, band pass characteristics. These are the references. And again, before closing the session, we will do our MATLAB session. So we will do corresponding first one will be for low pass frequency domain filtering. So there is a image football.jpg first. So this is the original image. This is the after low pass filtering. This is the output is showing. This is like this. And this is the Fourier spectrum of the original image. This is the Fourier spectrum of the low pass filtered output image. This is for the low pass filtered output. Now the high pass filtered output. Same image, we are doing the high pass. Now here we are taking here as Gaussian as the filter kernel. It can be changed to Butterworth and so on. We are for example we are doing this here for Gaussian kernel. So for high pass filtering, yes. This is the original image. This is the high pass filtered image. Sharpened image becomes sharpened. All the high frequency components are showing. And this is the original image frequency spectrum, and it is the high pass filter frequency spectrum showing. Now the last one, it is the bandpass filtering. Same figure. So it is the original image, it is the bandpass filtered output image. See, the bandpass filter output image is more, contrast is more. At the same time, the picture is showing clearly, this information is showing clearly. So this is all about today's work. So thank you. Bye.